Hello, everyone. I'm Raghotham Murthy. I'm an engineer in the GenAI team. And I'll be talking about the evolution of Llama from what was just a research model that was released last year to now a whole set of models that have been released recently. And furthermore, actually making it really easy to use through what we're calling Llama Stack. So Llama, as you know, has been around just for a little over a year now. And we have had many, many companies being able to offer GenAI capabilities to their own customers because of these open source models. And Llama itself has evolved quite a bit, and there have been folks in the industry who have kind of compared that to Linux and take this kind of operating system analogy. So when you think about when Linux was first being built out, there was a limited set of hardware that was available. This was the i386 back in the day in Linux. And for Meta, when they were building Llama, it was kind of the very early versions of GPUs. And from memory, it was also very small on the Linux side. In Llama, this is more around, or for models, it's more around sequence length. This was more like 2K to 4K. And in terms of the input and output modalities, as you know, in Linux back in the day, it was mostly just text in a console. And even with Llama models, it was mostly just text in and out. And as far as the developer experience was, in Linux, of course, it was just basic user programs that was being built by the community, by the ecosystem. And it was the same. And probably even now, for the vast majority, it's still the same. For people actually using Llama models, it's mostly kind of community driven. So earlier this year, we started releasing Llama models, the versions 3 and beyond. And we started getting better in terms of the number of types of hardware that we end up supporting. So recently, in our Connect event last month, we released really small models that can allow people to do on-device inference because of how small the models are. And in terms of memory, again, the sequence length, we're able to get up to 128K sequence length, which again allows you to have much better application support as you're building more and more types of applications. And in terms of modalities, we recently announced image reasoning as part of the models that we ended up releasing in open source. And for developer experience, we recently announced Llama Stack as a way to make it very easy for people to adopt Llama models, not only to just customize the models, but also actually use them in building agentic applications. I'm going to go a little bit into what we just launched because it's so fresh in our memories. In terms of the types of hardware support, the modalities, as well as more on the developer experience. So we released the small models. These are the 1 billion and 3 billion parameter models. And this was mainly driven by the fact that Meta actually supports billions of users that use Meta's products. And they would like to have these AI capabilities that they would want to take advantage of, but they don't want to give up on the end-to-end encryption that they have gotten used to. So having these really small models that can actually work directly on the device makes it so that a lot of these capabilities are now available for applications that don't really need the data to actually leave those devices. And these models, they were actually built by distilling and pruning from the previous generation of models that were much larger. There was the 8B and the 70B models that were released back in July. And these models, the 1B and 3B, were essentially distilled and pruned from them. And these models are text only. They actually are pretty good at doing things like text rewriting and summarization, as well as for folks that are interested in building like really cool applications, tool calling. The next set of models that we announced recently are the vision models, essentially giving Llama the power of vision. And these were built with a fairly unique architecture of the model itself through the adapter architecture. So the text inference is still the same, the backplane is the same, but then there were an image understanding adapters that were added. And this allows for image recognition, so applications like OCR and even understanding charts and graphs, things like that become possible. And at the same time, the models have the same capabilities as before in terms of the text capabilities that they already have. And we released in open source both the base and the instruct models. Yeah, and until about July, we've been mostly just releasing the model weights. So we put them out there, we tell the community, these are all the different capabilities of the models, we release evals. And then the actual usage of the models is mainly left as an exercise to the community. We do have like a very strong partner engineering team that is supporting people, but definitely we need something a little bit more. And we've been hearing from kind of two ends of the ecosystem, if you will. One is on the developers and the other is the providers. These are folks who are able to take the open source models that we have provided and then serve their customers. And you'll probably see a theme on this. From developers, clearly they love the flexibility of having open source models that they can customize to the extent that they need to, and also maintain control over their data and actually run the model in any and every environment that they have access to, be it kind of on-premises, it could be in the cloud, it could be even on-device or even on a single node. But they wanted to get started faster. There's a lot of really cool tools that are out there that people can use, but the combination of them makes it very hard for any developer to just get started, right? And the providers, and a lot of them are partners of Meta, they also love the fact that we are offering them open source models and the model weights, but then they have to do a lot of discovery on their end in terms of how to best serve their customers the capabilities of those models. So there are no really standards to build towards. So there are literally kind of one-on-one communications that we have to do with a lot of our partners to tell them how to, whether their implementations of their inference stack or their fine-tuning stack and so on are actually doing the things that they're supposed to. And because there are no standards, providers are also having to make sure that, they don't have the time to build everything. So they have to partner and they have to build integrations with everybody else that's out there. And that takes up a lot of their time as well. And ultimately, just like how developers want to get started quickly, even the providers, they want to build to some standards where the best practices are essentially codified and you don't need to have any kind of guesswork in terms of how to use these models. And while we were kind of hearing from our community, turns out we were building highly scaled apps internally at Meta. So we have Meta AI, AI Studio, and so on, where these applications, they end up using our models and they're serving hundreds of millions of users. And there's a lot of learnings that we've had in figuring out how to make the Llama models actually be usable and actually use them in building out these high-scaled applications. So we took those learnings and we started defining something called Llama Stack. And we started off by first just defining what the actual interfaces need to be in order to work with Llama models effectively. We wanted to make them a little bit more standardized. And it's not just for LLM ops or actually modifying or customizing models. It is also to build applications because turns out having the information in some sense and abstractions flow from model customization to actually building agentic applications is actually really helpful. So the stack itself contains two parts to it. One is the model toolchain API, which is also known as, I guess, LLM ops. So this includes all the things that are needed to customize a model. It could be fine-tuning, running evals. And it's not just about fine-tuning or just running evals on the model itself, but running evals at an application level as well. And then there's several primitives that you need in order to build agentic applications using not just Llama models, but any other models. So we defined a set of interfaces for each of those primitives that are needed to build agentic apps as well. And memory here just for is more of a general term for RAG, or retrieval augmented generation, if that's familiar to you all. So we defined the set of APIs back in July, and we just released that as an RFC. And the reception from the community has been great. And it's not only from developers, but also from a bunch of our partners. And last month, or a couple of weeks ago, we launched Llama Stack with a whole bunch of partners. So the way that we did it was, once we defined these standard APIs, we worked with partners to build implementations for these APIs. Just having a standard is not good enough. You need something that people can actually play with. And turns out there are many partners who are really interested in providing these standard APIs. And we worked with a lot of them. And turns out different partners only offered certain capabilities, not the entire stack of APIs. So we said, okay, we'll take a combination of a few API providers that actually work well with each other and build a single package called a distribution that will make it so that for a developer, it's just a single endpoint that they have to hit to be able to get all the capabilities of Llama Stack. And we have several partners here, including AMD, that we've been working closely with. So the developer experience with Llama Stack is actually much more straightforward than before. In order to actually spin up a stack, it's just a couple of commands, and you're able to run this internally on your own node, on a single node, or even in the cloud, if you will. But once you have a Llama Stack server or a distribution server running, the developer experience is as if you would had just an API that you would work with. And when you write your code, it's a few lines of code, you're able to actually very easily run it also without really having to piece together multiple tools. And note that even though the interface is very minimal, the actual implementation could be any one of those that I had talked about, right? And what I showed you here is just on a single node, but then turns out it's a very simple experience even for on-device inference. So I don't know how many of you are iOS developers, but this is fairly minimal for iOS in terms of adding kind of inference calls, and you're able to actually deploy it as an app with on-device inference very, very easily. So with Llama Stack, what we have found is that for developers, we have provided very easy to adopt APIs in multiple languages. It's Python, Node, Kotlin, Swift for iOS apps as well. And for developers, they have a choice of distributions that they can either use that are already provided by our partners, or they can build their own as well, depending on whatever combination that of API providers that they like. And of course, using these APIs and these SDKs means that they're able to get started very quickly and start building applications rather than having to wrangle a lot of the tooling. And for providers, because they're building to a standard, they don't really have to worry that much about having to integrate with like a bunch of other tools that are out there. And a lot of the capabilities that the ecosystem provides, it's really critical. But at the same time, certain providers may find that that is not where they would like to differentiate. So in those cases, they can just rely on the fact that other providers have built to these standards, and they can just focus on what they want to be really good at. And for the partners that are actually building towards these standards, Meta is investing in providing verification, like providing some level of support, so that when customers want to use Llama models with these distributions, they know that these distributions have been verified by Meta, right? Again, this is all just getting started. There's a lot that we'd like to do in terms of both supporting developers as well as providing partners. And we are also finding that hardware vendors like AMD are able to leverage a lot of these standards so that they can optimize their kernels, or like the work that they do, in order to support providing like really efficient implementations for their customers. And like I mentioned, we're just getting started. Going forward, clearly there'll be more and more capabilities of the Llama models that we will be offering. Longer context length, more paging, as well as like cross modalities, think about speech, voice, video, things like that. And from the Llama Stack perspective, build out like the full set of capabilities that any developer would need in order to be able to use these models. And of course, work with many more partners to make it so that a diverse ecosystem can actually grow with the open source models that we have actually built out. So I'll end there. You can scan this QR code, I guess, to learn more about Llama Stack itself. We're building all of Llama Stack in the open. It's on GitHub. And we've seen a lot of traction, even in the last couple of weeks that we have put it out there. We've had like thousands of downloads and thousands of stars in GitHub, which is pretty heartening to see. And yeah, with that, thank you, and have a great rest of the day. Thank you.